Assalamualaikum and selamat sejahtera. My name is Nuruliana binti Muhammad Yusof. I'm currently studying in University of Technology Malaysia in Bachelor of Science Computer in Bioinformatics. So today I will present about my project for subject probability and statistical data analysis. For this project, my topic for this project is actually homicide case report. So for today, I will explain about the homicide case report analysis. Homicide case reports are actually about the murder case that are currently occur in America. So actually the data that I got is from 1976 to 2014. So the data from 1976 are included in this report, which are made available by Murder Accountability Project. The database is actually based on the FBI Supplementary Homicide Report, and currently the data is not the exact number but the estimated number, because the classification are based on police investigation rather than coroner findings or judicial determinations. So from this, I use the methodology that carry out from secondary data from website kaggle.com, and it is made available by Murder Accountability Report. So the target population is actually for citizens of United States of America. So after the process of selecting data, I choose 500 data out of 938,454 data chosen from case in 2010 until 2014, approximately 5 years, and the data I choose is only for served cases. So this data from the database, the variables selected are gender, relationship, weapon, type of crime, and victim race and ethnicity of the victims. So from this data, I use the inferential statistics that carry out by hypothesis testing of two samples, correlation, regression, and chi-square test of independence and goodness fit chi-square test. For first analysis, which is hypothesis testing of two sample tests. This is we are testing about the claim of males are more likely to be killed than females. We know that actually America have higher potential of male to be killed than female. So in this hypothesis, we want to support the claim that males are more likely to be killed than female, expressed by proportion 1 is more than proportion 2. So the significant level we use is 0.05. So from the group murder, we choose the victim from murder or manslaughter, which is male. The number of male that are murder or manslaughter is 3, 4, 5, and the murder of female from murder and manslaughter is 1, 3, 2. So the total subject for male is 365 and the total subject for female is 135. From this test, we can see that the p-value for test statistic obtained by using R is 0.9037, which is more than conventional 0.05. So we know that if P is more than 0.05, thus we reject the null hypothesis. So there is sufficient evidence to support the claim that males are more likely to be killed than female. For second test, I use correlation analysis. So which is we choose the random sample from 500 homicide cases selected for this test. So we actually using the Pearson product movement correlation coefficient to test the relationship between homicide case and number of cases with weapon involved, which is the victim that were murdered by using weapon. So H null is actually we declare there is no linear correlation, and for H1 is linear correlation exists. So from this test, we can see that the p-value is actually 2.34 power of -6, which is less than conventional significant level 0.05. So we know that the value is less than 0.5 and thus we reject the H null hypothesis. So for the conclusion, we can conclude that there is sufficient evidence of linear correlation exists between homicide cases and number of cases with different involved. And the number of correlation coefficients is actually 0.9496174 at the 5% level confidence. From this graph, you can see that the scatter plot have a positive linear correlations, and as earlier I said, the coefficient value of R is 0.949, which is closer to 1. So we can conclude that this analysis have strong positive linear relationship between X homicide cases and Y number of cases with weapon involved. For the third test, we use the linear regression model, which is from 500 victims selected randomly from homicide database, and we declare that the independent variable in this case is victim race, and dependent variable is white perpetrator, which is white offender, white race offender. So analysis is to aim the existence of linear relationship between the variable X and Y. So from this test, we can see that the graph has shown the positive linear relationship with equation of y equal to -10.139201 plus 0.571392x. So the value of B0 is -0.139201 indicates that the range of white perpetrators on victim race, and the value of slope coefficient is 0.571392, which is indicate the victim race that were killed by white perpetrator. And from that result, we know that there is a relationship between X and Y based on calculation of P. The coefficient of determination R2 in this relationship is 0.755418, which is almost close to 1, and we can say that this is a moderate relationship. For the fourth test, I use the chi-square test of independence. So we select 500 victims randomly for this test. We would like to find whether there is a relationship between the between relation of victim and offender and gender of the victim. So hypothesis can be written as no relationship between relation of victim and offender and gender. And for the H1 is relationship between relation of victim and offender and gender exists. So from this result, we can see that the value of chi-square test is x squared, which is 9.8.9809, and the critical value is 3.841459. So we can conclude that since the value of x squared is more than the critical value, therefore we reject the H null hypothesis. So we can conclude from this analysis that the relationship exists between relation of victim and offender and gender. So in short, the relationship between the gender and victim and gender implies higher homicide cases in America. So for the last test, I use a goodness fit chi-square test, which is I need to observe about the male victims that were killed with equal proportions for 12 months from 2010 to 2014. So this is a table from January until December. From these results, we can see that the goodness fit test value is x squared equal to 15.877, and the critical value is 19.67514. So since the value of x squared is less than critical value, so we can conclude that we failed to reject the H-null hypothesis. So there is sufficient evidence to conclude that the proportions for 12 months in 2010 until 2014 are equal. Okay, this is that's only for my presentation.